Hi and good day everyone. Alright, so for this video session, I will discuss about basic data simulation. Okay, so this is actually our last topic in our programming. Alright, so what is means by data simulation? Okay, actually when we're talking about simulation, it is very important topic, okay, for statistics and any other areas. Because of what sometimes we might not have an actual observation of a particular events. Okay, so what we only have, we can only simulate the situation, and this particular situation they follow certain probability distribution as example, right? When we want to estimate, we want to do experiment based on observation, okay, and we assume that this observation following a certain probability distribution, that is how we use data simulation. And R actually comes with we call it as pseudo random generators that allows us to simulate from well-known probability distribution. Okay, but for this particular topic, we will only discuss four probability distribution, which is uniform distribution, binomial distribution, Poisson distribution, and normal distribution. And the most well-known, I think, is normal distribution. Alright, so let's take a look on how we can produce this output. Okay, and for this basic data simulation, I will only highlight on how to generate a random numbers. Okay, so depending on what you want, what you want to produce the output. Okay, it's actually depends on the initial letter that you put in front of the distribution. Okay, example, if you put R in front of the distribution, it is for random number generate. Okay, and then if you want to produce the density for the probability distribution, you put D, and also P for cumulative and Q for quantile function. Okay, so that's example. But again, so this is the function look like. Okay, the initial letter here is very important. Okay, depending on the letter, okay, R will produce the random output based on whatever you want. Okay, and for this session, I will only highlight about generating random numbers. Okay, so the function that we use is, okay, for uniform distribution, R unif. For binomial distribution, R binom. Okay, for Poisson distribution, R poise, and for normal distribution, R norm. Okay, so for each of these function, they have argument here. Okay, so this argument is the parameter that needed in the probability distribution. As example, for uniform, they need the mean and max, and this is n is the number of observation, or how many random numbers that you want to generate. Okay, for binomial, you need the argument that you need is the parameter that you need for binomial distribution is the size and the probability. Okay, so n here is the how many numbers that you want to generate, and then for Poisson distribution, you need lambda. Okay, and lastly, for normal distribution, you need mean and standard deviation. Right, so let's take a look at the example. I'll show to you the example. Okay, for uniform distribution example here, we want to generate a number of sales. Okay, number of sales where we for this particular sale, this is about flowers. when the maximum is 40, okay, and the minimum sale is 10. So we want to generate the random number based on this particular event for how many days? 20 given days, right? So we use this function, okay, okay, and then you run. Okay, so the uniform random number generator will provide us with this particular number. Suppose that you don't want the decimal places, you can put round here, just put 0, okay, and then you run. So for 20 given days, okay, the sales is 32, 23, 39, 27. So this is the sales based on uniform distribution. Okay, so let's take a look on binomial distribution. I'll just go to the example. You can read later. Okay, and okay, for binomial distribution, suppose that what the parameter that I need is the size, the number of the size, okay, the size for number of trials, okay, and I need probability of success. So based on this example, okay, a survey from a group project found that 30% of the students receive their spending money from part-time jobs. Okay, so this is the probability. So now I want to generate 10 random numbers of students who receive their spending money from part-time job. Okay, so since that 30%, this is the probability from part-time job, so the probability of success here is, okay, you have to use in terms of okay, decimal places. Okay, 30% is 0.3. okay, and then for each of the selection, 5 students are selected at random. So we select 5 students at random 10 times. Okay, so what is the output? Okay, so when you the first time, from 5 students, there are actually 2 students who do part-time job. Okay, and then you randomly generate, and then the second time, from 5 students we got 3. So this is only a scenario that we create based on random number generator, and this particular random number is based on binomial distribution. Okay, so that's the second example. So let's take a look at Poisson distribution. Okay, for Poisson distribution, unit rate, okay, unit rate, or we say lambda. Lambda is the rate at which an event occurs, and based on these examples, okay, we take a look on washing machine in a self-service laundry. Okay, their breakdowns on average 3 times per month. So this is your rate. So this is your lambda, 3 times per month, and then we want to generate random numbers for any given 12 month. So what you do, okay, I can write here, put here lah. Okay, then you run. Okay, so for any given 12 month, we will get 4 broken washing machine breakdowns. Okay, 1 washing machine, okay, and so on. So that's how you look at this example. And lastly, for normal distribution, the parameter that you need to generate random numbers is the mean and the standard deviation. Okay, try to find this parameter based on your example here. Okay, so for this example, we take a look at the hours children watch YouTube weekly. Okay, suppose that we have an average, and average is the mean, 25 hours. with the standard deviation 3 hours. Okay, you have to be very careful. If the question give you variance, make sure that you square root the value first. Okay, okay. Variance is the square of standard deviation. Now, if you want to get the standard deviation, you have to square root the variance, right? And then you just generate a random number based on the information given. Okay, right? And then you run. All right. So clear first. I run again. Okay. So you will get these random numbers. Okay. So any children, they will watch. Okay. 25 hours, 23 hours, 24 hours. Okay, so that's the example. Okay, and for this topic, the last point that I want to show to you is setting the random number seed. Okay, what is the random number seed? Okay, as we can see here, if I keep run or I keep generate this random number, every time I run, every time I generate, I will get different output. So what if I want to reproduce the same output? If you want to reproduce the same output, you have to put set seed function before you run the random number generate. Okay, and you can choose any numbers. Okay, any numbers. As example, I use 12 here. Okay, you run set seed 12 or no. Okay, and then again I run set seed 12 or no. Okay, so here you will get the same output. If you don't run set seed first, what you get different output every time you generate random numbers. Okay, so that's set seed function. Okay, it's actually essential for you to set this random number seed so that you can get a reproducibility of your sequence of random numbers. Okay, right. So you can try take a look at my example in this slide. Okay, and for summary, for random number generate, you have to put R. Okay, and then you choose the probability distribution. What are the random number that you, based on what probability distribution that you want to generate your random numbers. All right, and this example we use uniform, binomial, and Poisson. Uniform, binomial, Poisson, and normal. And each of these distribution, they need parameters. Okay, they need parameters. Okay, depending on the distribution, you need parameters. Okay, so find out the parameters if question based on question. Okay, and then to get a reproducible output, you have to use set seed function. Okay, alright, so I think that's all for this video session. Okay, thank you for listening. Bye.